Here, a body of mass 60 kg is pushed up with just enough force to start in moving on a rough surface with mu s equal to 0.5 and mu k equal to 0.4, and the force continues to act upwards. Then what is the acceleration of the body? G value you take 9.8 meter per second square. If you do this problem, we are getting answer 0.98 meter per second square. What is the mu s? Coefficient of static friction. What is the mu k? Coefficient of kinetic friction or coefficient of dynamic friction. Now we are going to solution. If you keep any block on a rough surface, mass of the block, if you take m, mg acting downward, perpendicular to plane of contact, one force exerting, that is called normal reaction. So in this case, simply normal reaction equals to mg. If mg weight more, it moves downward. If normal reaction more, it moves vertically upward. This is not possible. So vertically no motion. So no need to consider the acceleration. So but when we are applying here some force F, then only here frictional force created. If there is no applied force, frictional force equal to 0. That is very important thing. Now I am applying some force. Which type of force? That is slightly more than the maximum static frictional force, because it is just enough to give the motion, is that is just slightly more than the maximum static frictional force. So this F is called FMS. Then only body slides. Now here what happening? Applied force like this, frictional force like this, but system moving like this with some acceleration of A. Now you take FBD. What is the FBD here? mg downward, normal reaction vertically upward. Here one applied force, this is opposed by frictional force. System moving with some A acceleration. System moving in this direction, so definitely applied force is more. Now what is the F net? F net equal to applied force minus frictional force. So applied force minus frictional force I am taking as FMS, because slightly more than the FMS, if you apply, then only it starts. Now F net, that equals to F minus, what is the FMS? Mu s into mg. So if the applied force is slightly more than the mu s into mg, then only system moves. So here when it is moving, some friction force generating, that is called kinetic frictional force. Initially F equal to FMS only, slightly more than that F applied, he had given. So here F equal to FMS. When system moving, what generating? Kinetic friction force. So this you take Fk. So what about FMS? FMS equal to mu s into normal reaction. Normal reaction equal to mg rating. Again Fk equal to mu k rating into normal reaction, again mg rating. Since mu equal to F by K, otherwise F equals to mu into K. This is the process. If it is FMS, mu s rating. If it is Fk, mu k rating. That's all. What is the formula for F? Ma. So mass of the body I am taking m. So ma equals to, here I am taking mg common, mu s minus mu k. So m cancel. Finally I am getting as mu s minus mu k into g. So this is the formula for doing like these problems. If the applied force is slightly more than the FMS, then only system slides. If you continues to act on the system, then what happening? It moves some acceleration. When one block moving on a rough surface, it is having some constant frictional force, that is called kinetic frictional force. So it depends upon the condition we are doing. Now substitute all values in this equation. Till now this implies A equals to, what is the mu s value? 0.5. What is the mu k value? 0.4 into 9.8. So A equals to 0.1 into 9.8. So finally I am getting as 0.98 meter per second square. So this is the acceleration of the system. Once you see all these things carefully, in this case applied force is slightly more than the maximum static friction force, then only it starts. When it is a sliding constant friction force it is having, that is called kinetic friction force. These two are the important things in this.